Hi students, this is the 1, 2, 3, 4, 5th video, and we are talking today about equations and molar relationships. Now, when we're talking about molar relationships, right, I've heard the word molar before, haven't I? Or maybe you have. Molar masses. We've talked about molar masses as being the amount, right, in terms of grams of a mole of a substance. Okay? So, we're going to look at the relationships. All right? So, we're going to start off with an equation and a question. All right? Why are chemical equations and molar masses useful in answering questions about large-scale reactions? Okay? Going back to our original equation, all right, with copper oxide making copper metal. Again, this equation is very important. However, if we continue to talk about the atom level, right, we will lose, all right, the interest of the manufacturers and the refiners and the large-scale, processes, right, that those people work with, right? They're dealing with tons, right? Many grams of things. So first, we have to think about it in terms of our lovely, right, mole, right? The mole helps because it's a very large converting factor, or a unit, right, that helps us to get on the scale, or start to get on the scale of, large quantities, right? So looking at this, we have two copper oxide, right, molecules. To convert that to moles, we just say there are 2 moles, right? Again, this is just a proportion, right? So if we have 2 moles of copper oxide, and you're looking at an equation, we must have 1 mole of copper. What does that make? 2 moles of copper metal and 1 mole of carbon dioxide. Okay? This lets us say that for every 2 moles of copper oxide that reacts, 1 mole of carbon dioxide is produced. Okay? So we just took a basic equation and converted it into moles. Okay? The proportions are correct still. That's important to note. All right? Now, once we have moles, we can go to mass. All right? Now this is an important step here. Going from moles to mass, how do we do that? We have to use our molar masses. How do we get that? We go to the periodic table of elements. Again, where is it? I have my trusty book. I have it close to me all the time. It's close to my heart. I love it so much. All right, it's right here. So you need to make sure that you have your periodic table close. Okay? So 2 moles of copper oxide. Okay? What I do is I add up the molar mass of copper, the molar mass of oxygen, right? And I get 79.55 grams. Type it into your calculator there. You should get 79.55. Why? Because copper is, 63.55 grams. And oxygen is, 16 grams. 63.55 plus 16 equals 79.55. Hello. All right. So we have 2 moles of copper oxide. Therefore, we have 59.1 grams of copper oxide in this particular equation. There are 2 moles. All right. Let's do the same thing for copper. But copper, we only have 1 mole, right? So molar mass is the mass of 1 mole. So if we look at the periodic table, we see the amount. Ta-da! 12.01 grams. That's easy. Oh, we go over to the product side. Copper has, 2 moles. So we have to multiply it by 2. So the molar mass of copper is 63.55 grams. All right? Multiplied by 2 is 127.10 grams of copper. Okay? Now, probably the most complicated. It has 3 atoms, right? This carbon dioxide, right? 1 mole of copper, right? The molar mass of copper, or sorry, the molar mass of carbon in this carbon dioxide is 12.01. We just found that, right? We have oxygen there as well. Oxygen is 16 grams, right, per mole. And we have 2 oxygens in a carbon dioxide. So 16 plus 16 plus 12.01 equals 44.01. Okay? We have only 1 mole. All right? So that's our molar mass for all the reactants and products in this particular equation, chemical equation. Now, compare the total masses of the products and the reactants. Do you notice anything peculiar? You should notice that this illustrates the law of conservation of matter. Why? Okay? You want to note that the total masses of the products and the reactants are equal. Equal. Okay? That shows the law of conservation of matter is upheld. All right? Yay! That's a good thing. Okay? That shows that we've balanced our equation. All right? We've added up everything correctly. That's a good way of checking. Okay? Now, this is an important process, going from, as we said, moles, right, to molar masses. So, where do we use this? In metal processing companies, they typically work with large quantities, rather than just several grams. Therefore, they produce more than 1 or 2 moles. All right. They rely on chemical equations like what we had there above, all right, but they need to make some calculations, right, to convert it into large-scale reactions, right? And so we need to understand the relationship between the particular parts of the equation, right? So, for example, 2 moles of carbon or copper oxide, right, plus 1 mole of carbon, right? Those relationships, 2 and 1, right, will be magnified into large scale. So let's give an example here. Let's say a refiner needs to convert 955 grams of copper oxide to pure copper metal. Okay? And in order to do that, he needs to figure out, or she needs to figure out, what is the mass of carbon, C, right, for this particular reaction, right? So what do we do here? Well, the first thing we need to do is convert it to a unit that we like, right? That is useful to be exchanged throughout. What's that unit? Let's use our wisdom from Amedeo Avogadro. Avogadro's number is 6.022 times 10 to the 23rd, which is the mole. So let's convert to moles. 955 grams of carbon or copper oxide. All right. So let's convert. How do we do that? Well, taking a look, 1 mole of copper oxide, right, is 79.55 grams of copper oxide. We already figured that out up there. Okay. What we want to figure out is, if we have 955 grams of copper oxide, how many moles is that? It's definitely more than 1, right? So how do we figure that out? We put a proportion there, okay? So if we put a proportion there, and I'm going to move this up here, because we're going to need this in a sec. If we put a proportion there, all right, we can figure it out by cross-multiplying and getting the X, right, from X moles of copper oxide. We figure it out, all right? So we cross-multiply, and you should do this with your calculator. You should get that you have, for 955 grams of copper oxide, you have that's 12.01 moles of copper oxide. Okay? it's important to note that we had to use something called a conversion factor, right? We used 1 mole of copper oxide, right, over 79.55 grams of copper oxide, right? That was useful to then take the 955 and convert it into, right, moles. So that was an important part. That was a converting factor, all right? So what do we have? We have 12.01 moles of copper oxide. We're not there yet, right? What we have to figure out is how many moles of copper is that, right? How many moles of copper will you need if you have 12.01 moles of copper oxide? Sorry, when I say copper, I meant carbon, right? We're going to carbon. So if I have 12.01 moles of copper oxide, what we do is we multiply it, again, by another converting factor. Conversion factor here, right, is 1 mole of carbon, right, for every 2 moles of copper oxide. Why do we do that? That's interesting. Well, we do that because now what we can do is cancel out the moles of copper oxide on the top and the bottom there. See how they cross out? All right? And what are you left with? You're basically left with moles of carbon there. Left with moles of carbon. Ta-da! And that's a good thing. Okay? So we divide 12.01 divided by 2, and you get 6.005005 moles of carbon. And finally, we have to convert to grams because we need the mass. So how do we convert to grams? Well, we have 6.005 moles of carbon, and I know that each mole of carbon weighs, wait, where should I look for this? Weighs, moles, weight, molar mass. Molar mass is on the periodic table. Oh my gosh. All right. And we take a look at the periodic table and we see that for every every mole of carbon, we have, well, I'm going all over the place. For every mole of carbon, it's 12.01 grams. And so we use this conversion factor again, right? And we're able to cross this out, okay? And what we're left with is just grams of carbon, okay? And this is the answer here. Yay, 72.12 grams of carbon, all right? And we're left with the answer, okay? What is a conversion factor then, you might ask? A conversion factor is a proportion that is used to convert from one unit to another, okay? So from grams to mole, moles to grams. We use those often, all right? So I hope this was helpful, and for the next video we will practice more of these problems. Bye.